Good afternoon and welcome to today's webinar. My name's Charles Green and I'm the marketing here today. Firstly, thank you all very much for taking the time out of your day to join this call. And today we're going to be discussing performance testing, which has become more and more important, particularly as the users of software have increasingly high demands and even less patience with software which is slow or doesn't really meet their expectations. So to discuss performance testing and delve deeper into the topic today, I'm delighted to be joined by my colleague, Lee Lopez. Lee, do you want to introduce yourself quickly?
Hey guys, how are you? Well, my name is Lee Lopez. I'm from Peru. I'm working here in Bellatrix more than 2 years. I'm involved also in performance projects 5 years ago, which allows me to have a kind of experience doing this kind of tests. I've been working in projects like banking projects, also social media projects, and every kind of application related with high demand of performance. And today I will share with you some knowledge about this kind of tests.
Okay, excellent. Thank you, Lee. And just very briefly, before we get started in the presentation, just very briefly about Bellatrix, for those of you who are not familiar with us. We are a leading provider of software development services with expertise in product and mobile application development. Our focus is on innovation and really shaping the concepts and ideas of our clients into world-class software products. And we have delivery centers in Mendoza and Buenos Aires in Argentina, as well as Lima, Peru, which is where I'm based, as well as Lee as well. And also we have a delivery center just opening up in Bogota, Colombia as well. And finally, I want to mention that today's session is very open. So while we will be presenting for much of the next 30 minutes, please feel free to ask questions either by the chat box on the right-hand side of your screen, or via Twitter, where we're going to be live tweeting throughout using the hashtag testingbsf. So you can follow along with the presentation on Twitter, as well as the presentation from Lee, but also use that, of course, to ask us questions as well. But without further ado, I want to now pass it over to Lee to kick off the presentation.
Okay, thank you, Charles. Okay. Are you already seeing the screen, right? So let me tell you basically what I'm gonna show you today is a brief summary of what performance testing means. Also, in which cases is the performance testing advisable? Why it's so important to include this kind of tests in our software development cycle? What kind of tests are related to performance testing, because performance testing involves a lot of testing, a lot of different tests. What do I need if I want to include performance testing in my project? And finally, I'm gonna share with you a brief case of what are we doing here in Bellatrix. Okay. So I'm going to start with this image because according with Strange Loop blog, 1 second of delay is in the response time of our website could be cause a lot of loss of 7% of sales. Also, it could be mean that 11% fewer pages views, maybe losing potential clients, right? And also 16 decrease of in customer satisfaction. What does that mean? That probably that our customers will leave us and look for our competitors, right? And also, but what is that mean in money terms? It's important, right? Money always is important. Well, it means that if we earn 100,000 by day in sales, we could lose 2.5 million by year, which is a lot of money, right? Having in mind that the cost of this loss was only 1 second of delay in our website. So it's very, very important for our business, for our website, give a good satisfaction for our clients, and it means, in performance terms, it means lower response time from our page, our web page. Okay. So first of all, let's define what performance testing means. All right. Well, basically, it is considered as part of a non-functional test group. What does that mean? Well, if you are guys know about how the testing is divided, there are functional and non-functional kind of tests, right? Well, performance testing belongs to non-functional tests, and also, unlike in functional testing, here the main focus is the symbiosis between application and environment. We not only focus in applications, we need to focus in application and environment. Probably a lot of us think that performance testing is just a kind of test, but actually performance testing is like a label to name all different kind of tests that has different goals, like load tests, soak tests, stress tests, etc. Well, from my point of view, it's an essential part of performance development cycle, because each new release has to be tested in order to see if new changes or features may improve or not the general application performance. Don't forget that good performance is a matter of perception. For some websites, like for example file storages, 60 seconds of response time could be a good timing for download or upload files. But if our website is a money transfer, for example, business, make our customers wait for 60 seconds till confirm that the transfer was successfully sent or not, could generate distrust and maybe loss of customers, right? Our customers don't want to wait too much time. Each module also, or layer or server in our performance test environment is a study case itself, because when we evaluate the performance of our system, we need to evaluate the performance of each module of our system is made. It's very important to have that in mind when we are trying to do a performance testing. Okay, now we are going to talk about where is the performance testing site inside our project. Okay, because we have our project to develop our software, right? And inside that project, we have a small part which could be the testing project, right? The testing effort. Also, inside the testing effort, we need to include the performance testing, and what I say can be considered as a smaller project inside the general testing project, where each stage is composed by tasks, as you can see. It's important to mention that early stages cannot be bypassed because are very important. There is where scope, goals, and requirements are defined. So it's very important to not bypass them. Then we have the design stage, where the scripting is made, when we need to configure all data and also configure our performance environment. Then we have the testing part, all the tests that we need to do to evaluate the performance of our application. And finally, we have the closure, or the final stage, when we need to communicate all the results to our customers. We need to tell them how the performance is going on, how the metrics that they define at the beginning are being accomplished or not. Okay, so what can I do in performance testing? It's a very important question. Basically, what we do is, well, we need to humanize the robot. It's a very important topic, because what we do actually is replicate or simulate a lot of concurrent users interacting with our application, with our system. It's really important to make the right scripting, because the scripting is the base to the performance testing. Our script is the responsible to emulate what the humans or the users are doing with our application. So not all tests has to be made by scripting also. Consume one single web service or run maybe a JDBC process can also be used to run a performance test. I mean, not only the scripting is necessary for run performance testing. We can do it only consuming one web service or one JDBC call, maybe. And also, it's very important then when we run our performance testing, we need to monitor the environment. We need to also export and correlate results, because it's very important to know what is happening, what is going on with our servers during the performance test. And also, as I say, we need to communicate, also do the analysis and diagnosis of our application and communicate with our customers. So there are plenty of tools in the market that we can use to do a performance testing. There are a lot of tools available to design and run scripts, but many of them are licensed, as you can see in the screen. But there are a few, like for example, JMeter, which is open source and free of license, and we can use it also to run a small maybe performance testing, because as the tool is free, well, it has some difficulties or maybe some problems compared with others that are licensed, right? But it's a good start. It's a very powerful tool as well. But in the market, there are a lot of there are plenty alternative to choose, depending which protocol is made our application, or maybe how many concurrent users we need to emulate. Depending of that, we need to evaluate which performance testing tool we need to for our project. Also, there are another tools which allow us not to run and execute performance testing. They allow us to monitoring and evaluate how is the performance in the servers, in the server side at the backend. These tools can monitoring everything, can monitoring operating system consumption, like CPU percentage, like memory, like bandwidth, or maybe monitor application servers, like database, like web servers, JVM. No matter what technology have you in your system, I'm pretty sure there are the correct tool to monitor the performance in your system, because by now, well, there are a lot of technologies. There are different technologies that can be monitored by these kind of tools. But there is let's say a problem, a difficulty, because some of them are very expensive and charge you by number of servers, by throughput generated, by time maybe. Well, and we need to invest kind of money, because there are no cheaper. Okay, so it's very important to know what technology we have in our system, and then evaluate what tool or what software we need to monitor it. Okay, but although performance testing is very cool, not always is advisable. So we need to analyze the cost benefit of applied performance testing in our projects. Okay, so there are some quick questions to know if we need or not performance testing in our projects. So for example, if our application is succeed by just a few users, doesn't make sense apply performance testing in our projects, right? But if our application is succeed by a lot of users, a lot of concurrent users, it's very important to do this kind of test and emulate that scenario and control it by monitoring, and also check if the servers are down or not. Another case is when for our business the response time is critical. Maybe if we are banking activity, we are in banking activity, make a money transfer is very important, very critical, and we need to evaluate how is the response time going. Another case is when our system is placed in a distributed architecture, because if our system is only one server, it doesn't make sense to do performance testing, right? But if our system is made or with a different kind of servers, for example, web servers, application servers, database servers, then it's very important to know if one of those servers is could be a bottleneck. So it's very important to know, to recommend performance testing in these cases. Also, if the servers of our architecture share the infrastructure with another components, right? Because now is what is going on now is there are a lot of servers in the cloud, right? So in the cloud, we don't know if our server is a private server or maybe sharing infrastructure with another servers. And that is why we need to evaluate the performance of our servers in those cases. And also, if our application is an e-commerce software, we need to it's very important to recommend the performance before sale campaigns, because in sale campaigns, there are a lot of demand, right? There are a lot of users trying to access to our application. So we need to emulate that in a controlled environment. So as I say at the beginning, performance testing is not one single test. It is, I would like to say that it's a label to name a lot of different tests that can be made during our development cycle process. Let's define one of them. Let's start with load test. Well, load test is I will say is the basic test regarding performance testing, because it's the it has the need or I will say the responsibility to respond the basic question, right? Which is, am I okay or not? My system is okay or not? It's the biggest and simple question that this test is responsible to respond. In this case, we simulate an scenario with expected conditions. Because, for example, if in a production environment we are trying to receive or support, for example, 100 users, we need to do a test, a load test, in a controlled environment with the same amount of users, in this case 100. So it's very important to do this test, because it will say us if our system is working okay or not, with all the SLAs that we defined at the beginning, right? For example, one SLAs could be the response time couldn't be higher than 10 seconds, for example, or the CPU usage cannot be more than 50%, for example. So these SLAs has to be defined and also be tested in the load test, okay? Where we do a metric of overall performance of our application. The second test is the scalability test. Okay, so now that I already did a load test and I already know that my system is okay, I need to respond the second question that could be, how much can I grow? With the same application, with the same environment, with the same servers, how much can I grow? So this is kind of define or respond the future expectation of our business. For example, if our business is thinking to open another succursal or another store, I need to know if I do that the growing process, my application is going to respond okay or not, or what do I need to respond okay, depending of the SLAs that I defined at the beginning. So I think it's very important to do this kind of test depending of the business that you have. The next test could be the soak test. This test is very cool because it can be defined like a load test, but executed or run it during a long period of time. I have participated in projects where where we run soak tests during weeks even, right? So how is this thing going? For example, I start a test Monday at the morning, and then we run the script for the whole week till the next Monday. So we need to monitoring, evaluate how the memory is going on, how the garbage collector is going on, of maybe there are memory starvation or not. So it's very important to do this kind of test because in real world, in production environment, our applications are on 24/7, right? Because we don't shut down servers or restart servers or anything. We need the application running 24/7, and we need the application respond okay in all that long period of time. So it's very important to do this soak test in a controlled environment. Next test is the stress test. This is the most commonly test, more known test, because everyone wants to break the system, right? Everyone wants to break the servers, shut down the servers, doing a big or creating a big concurrencing of user, right? So this is very important test for depending of what business do you have. So let me explain. For example, in this case, what we need to do or what we want to do is break the system. This is the focus. We want to know where is my system weak. This is the main point, because in an unexpected environment or unexpected conditions, I need to evaluate what is going to happen if my system breaks. For example, for airports or maybe for hospitals, if the system breaks, I need to know what is going to break first. I need to know if my database server is the one that is going to be in trouble, or maybe my application system, or maybe the bandwidth. I need to know what is going to break first. So I need to make a business continuity plan to mitigate that that break, right? So as I say, depending of the business that you have, it's recommended to do this stress test or not, but it's very important. Also, there are other kind of tests, basically there are recommended for that. Let's say the scripting process. For example, the bug. The bug is like a test my own script testing, right? It is basically important because I need my script to work okay, right? So I need to debug the script, make sure that everything is going right. For example, the smoke testing also is very important because I need to run also my script that I know that is working okay, but I need to run it with concurrence. I need to know how, for example, is it working my script with 10 users, with 5 users, for example. So I need to know to test my own script and make sure that the script is working okay. There are, for example, the baselines. The baselines are very important because this is like in every experiment we need. I need to have a base test, right? I need to have a base to compare to after compare with results of other tests. So baseline is that I need to have a base result, and then this result I'm going to compare it with a result of other tests. Okay, so also I have the profiling, which is very important for developers because profiling evaluate the performance of our code, our method, our classes. I need to evaluate how is the performance in a deeper level, which is code, store procedures, and etc. So it's very important to do this kind of tests also in the development software cycle. Talking about best practices, there are a concept or a framework right now, which is the application performance management. It has the responsibility to give us a guide to follow, right? Because it is like a book that I read to know when can I start, what is the next step, what I need to do, performance testing, how to evaluate it. So it's very important to know this concept because all the tools that are currently in the market are applying this concept in their software. So it's very important to know that, to have this concept in mind. For example, a lot of new technologies have support APM in order to manage the good performance, as you can see in the screen. If you identify one of these as part of your work, you may explore new features in order to improve your current process. There are a lot of tools like Docker, Jenkins, Node.js that currently have APM modules inside their softwares, because APM is a concept, I will say, the future concept of performance testing. So it's very important to have it in mind. Now let's talk about the environment. So environment is very important because, as I say at the beginning, performance testing has for focus the application and the environment, not only the application. So we need to consider to run our performance testing in a controlled environment, but this environment has to be similar. I mean, sometimes it's difficult to be equal to the production environment, right? But it has to be the most similar possible to our production environment, so we can test and give more exactly results. For example, in this case, in this graphic, there are a business that has a lot of servers, as you can see, load balancers. There are web servers, host servers, and let's say that this is the environment that we need to test, right? But we need to replicate that environment. So this is the environment that we have in for real. Yes, this one. This is environment that we have in our hands to make the performance testing. And I bring this example because it's a common example in real life, because emulate performance environments is very it's not cheap. Okay, we need to invest a lot of money in order to replicate the production environment. So at least we need to have servers or environments that not like like a production environment, but at least that could be similar. Okay. Okay. Now that we know that the environment is that the environment is the most similar to production, we need to define our performance test architecture. Okay, it's very important to know that because as other tests, we need to make our own architecture to run our performance testing. So the architecture is basically composed by a controller, okay, which is the let's say is the brain of the operation. Also, there are the load generators, which are controlled by the controller, and we can say that these guys are like the muscles of the performance testing, because they are in charge of generate all the load, all the simulation of virtual users. So we need to the load generators to be installed in powerful servers. Okay. Now with the technologies, we have load generators installed in cloud, in internet. So there are a lot of alternatives that we can use to generate our performance testing. These load generators are in charge, as I said, to emulate different protocols, different users, different devices like browsers, mobiles, tablets. Okay, and these guys point to the servers, okay, to our performance environment. And in the performance environment, it's important to have monitors. Okay, the monitors are very important because they tell us how the servers are behaving during the performance testing. So also these monitors can be controlled by the controller depending of which tool are we using. Okay, how much money did we invest for the performance testing, and we can centralize all the information in only one screen, which is very cool. But basically, this is the architecture of every performance testing should have. So what do I need to start my own performance testing in my project? First of all, we need to make sure that our code is ready and is frozen. Okay, because it's very difficult, very hard to have or to try to do a performance testing during the development cycle, because in the development cycle there are a lot of changes, a lot of modifications that can affect our scripting. Remember that the scripting is the most important part, because in the scripting we recreate the behavior of the humans. So if there are a lot of changes in the application, maybe our scripting could generate errors, or maybe it could be outdated. Okay, so it's very important to have the code ready and frozen. Also, design our performance test environment. As I show you in the previous slide, we need to define how the environment is going to be. First of all, try to simulate or recreate the real production environment. Try to have similar servers, maybe different similar technologies, of course, and also define how it's going to be our performance architecture. As I show you, we need a controller, we need maybe another a lot of computers to generate the load depending of how many users we can recreate. So it's very important to define all this kind of stuff first. Okay. Also, we need to set realistic performance targets. It's very important because, for example, if I have a small business with a lot, for example, a few users, also I have few laptops, I don't have too many resources, I cannot pretend to do a huge performance testing, right? And try to test a whole server, a whole environment. So we need to establish realistic performance targets, okay, depending of what what I have for resources. It's very important. Also define and create scripts to emulate the transactions. Do our script the most similar to the human behavior. It's very important to have success in our performance testing, right? And also another very important topic is the data to test. Remember that performance testing needs a lot of data in order to emulate all the cases, all the transactions. So in many cases, I have seen that because there are not enough data, performance testing project dies because there is no way to replicate all that transaction because there are no data. So it's very important to have that in mind previous to pretend to start an performance testing. Well, then also run the test, and monitoring is very important. Not only generate the load, not only replicate the human behavior is important. It's important as well monitoring, knowing what is happening behind our eyes. I mean, what is happening in the server side. It's very important to know that because if we want to do a precise diagnosis of our system, we need to have eyes everywhere, right? We need to see every possible bottleneck in our system. Then we need to interpreting results. There are, as I say, tools in the market that can help us to centralize all the information, to show us like graphics, like charts, because at the end of each test, we have a lot of data from servers, data from our controller, data from for example, the monitoring that we did. So there are a lot of data that we have to analyze and interpreting. So it's very important to maybe if our system have a lot of servers, maybe thinking in buy or a tool to do that for us, right? And centralize all the information. And finally, but it's very important as well, we need to summarize correctly the results of our performance testing, because in teams, in project teams, there are different kind of people. There are executive people, there are technical people that the information that they want is not the same. For example, for executive people, we need to present summarized information, like how is the application is going okay or not, or for example, how many I invest in license and how many concurrent users my application can support, etc. But for example, for technical people, we need to give a more detail, right? For example, how is the servers behaving? How is for example, the CPU, the memory, if there is starvation or not? Where is in which part of the code is generating the contention of the system, etc. So we need to focus our results depending of the people that we want to share the information. So finally, I want to share with you guys one case of study. What are we doing here in Bellatrix? Because it's very important to compare with in real life, right? It's very important to know what is happening in real life. So here in Bellatrix, our work is basically simulate transactions of several thousand of users. Okay, our users, what we emulate is a mobile application. It's a banking business. Okay, so our customer is in the banking business. So we simulate the load from a lot of thousand phones trying to connect to our system. Okay, in our environment, we are in charge to install every version of the application, install monitoring tools, start or stop the application whenever we want. So we are in charge of manage our own environment. Okay, and also we use a backend simulator in order to protect critical data of our customers, like users, bank accounts, credit cards, etc. So we use a backend simulator, well, in this case, to protect the critical information. It's very important. The hardest part is test every possible change that can affect the general performance. In our case, we have a lot of, we work with the Scrum, okay, the Scrum methodology. So in Scrum, there are a lot of changes. In each sprint, there are a lot of changes that could be affect the general performance. So what my team is in charge to do is test every single change or every single improve or every single difference that are between how the application was at the beginning and how it's going, how it's pretending to deliver in the new release or the new version. So it's very important to do this this process cycling, right? And finally, I will like to share with you what technologies are we using in our project here in Bellatrix. We use Scrum as a methodology. So in each sprint and releases, we need to validate if small and big changes improve or not the general performance and accomplish with acceptance criteria or not. Certainly, our best ally is cloud virtualization to place our performance environment using enterprise cloud computing and simple storage service to storage different kind of data like logging or test results and stuff. Remember that doing a performance testing means that I'm going to generate a lot of data, so I need a place to store everything. All the important things, I need to store them. We have also used Jenkins to manage our test suite, centralize our performance testing plan, and using JMirror and project where we are able to use Jenkins to run our performance tests and Jenkins jobs, which is really cool actually, because it means that with few clicks only, we are able to run a test, collect and also store statistics and have a summary of what was okay or not. It's very cool actually. We have developed Jenkins as our own performance tool. It's very cool. For monitoring purposes, we use real-time monitoring tools like a New Relic to see how the statistics of consumption of our environment, and also we use Dynatrace to see the detail of what is going on at code level, I mean a deeper level, which is a huge help for development process. It's a huge help also because we are able to see in real time, I mean during the execution, we are able to see which part of the code is making bottlenecks or which part is generating the congestion of the system. So we use all these tools in order to improve the general performance of our application. And after all the process that we do, we need to also investigate, because every time there are new tools that we can apply in our process, in our project. We need to investigate which tools are in the market, which tools, depending, making a cost-benefit analysis, which tools are recommended or not for our project. So it's a matter of investigation as well. Okay, guys, I think that's everything for me. I don't know if you have questions or comments.
Okay, excellent. Thank you, Lee. This is Charles again. Well, firstly, thank you very much for sharing the presentation. It's been very fascinating to hear about performance testing. As Lee mentioned, we have time now for questions from the audience, and just a reminder to do that, you can either ask a question using the chat box on the bottom right-hand side of your screen, or you can do it via Twitter using the hashtag testingbsf. But actually, during the presentation, we had a couple of questions which came in while you were presenting, Lee, which I want to jump to straight away. And the first one is, how is performance testing different for mobile applications versus traditional software?
Okay, thanks. Well, actually, mobile applications in performance testing terms is not different as regular applications. Let me explain. It's not different. We only need to understand which protocol is used by the mobile application. Normally, the mobile application use web services. That could be SOAP maybe protocol or maybe REST API. So we need first of all understand which protocol our mobile application is using. Okay, and then starting from there, we can develop our script. We can run our testing, monitoring, and do the whole process as a regular application. So basically, the important thing is know the protocol that my mobile application is using. Is the biggest difference.
Okay, thank you. And actually we have another question, which is, do you have any advice for determining the scope of performance testing?
Yes, of course. First of all, as I said, we need to evaluate what are or which are the critical business cases for my business. Okay. We need, for example, we can evaluate which are the more important for my business, which are the more time-consuming, which are using more data transfer. So depending of the need of my business, I can recommend which transaction or which test case I can emulate in performance testing. Also, it's very important to know that I have to have enough amount of data to emulate the transaction or the test case that I want to test. Okay, because if I don't have enough data to test that, I wouldn't have success at the end. Okay.
Okay, excellent. Thank you. Just waiting to see if any more questions come in. Just getting a quick reminder, you do it on the chat box on your screen or via Twitter. And actually, yep, just another question's just come in. How do you best determine benchmarks for your tools?
Okay, great question. It's very important. First of all, evaluate which protocol are we trying to emulate. Okay. Now, the applications, the most kind of application use protocols like HTTP or HTTPS. I will say that they are like the most known protocols. Okay, but there are a lot of protocols that we can test. So the first step to evaluate the tool is if the tool that I want to buy allows the protocol that my system has. Is the first question. Then I need to evaluate how many concurrent users I want to evaluate. I want to simulate. If my application, if I want to do a test with, for example, a couple of hundred of users, maybe I can use a tool installed in a local environment like my computer or something. But if I want to simulate 1,000 of users, I need to think that maybe a good idea would be install or use the cloud solutions that install the load generators in internet in cloud environments and start the testing from there. So it's very important to know how many concurrent users I want to simulate. Also, which technologies are using my servers, my backend. I need to know, for example, if the technology that my server has is allow us to be monitored by the tool that I want to buy. If not, maybe I will start to thinking that I have to choose another tool, right? Because the technology is very important. And the final, I guess, more important is the money that I have to invest, right? Because if I don't have enough money to buy the tool, maybe I need to obviously buy maybe less models, or maybe thinking and buy a tool that doesn't cost too much. And well, always money is the most important part.
Okay, excellent. And I think we have one last question which has come in, and that is, in what phase or moment of the life cycle of a system is it convenient to execute performance tests?
Okay, great question. Actually, it's recommended, highly recommended, do the performance testing at the end of the testing of the manual testing process. Let me explain. Because in the software life cycle, there are development process, then the testing process, right? So we need, for performance testing, we need an application that has not bugs or has not errors, because we are in risk of our script can fail or can show errors that won't be generated by the load. Instead are generated because the application has not been tested, or because the application has errors, functional errors, I mean. So it's very important that at least the cases that we are trying to test in performance testing has been validated by QAs or by QA teams or developers, and certified that that's the happy path, I will say. The happy path has to be free of bugs, free of errors, and then we can start the scripting of our performance testing and then run the test. So the answer will be at the end of the testing process.
Okay, perfect. Thank you very much, Lee, for answering the questions so far. I see we don't have any further questions from the audience at this time. And I see we're nearly at the top of the hour as well, so I think this is a good time to bring the discussion to a close. I'd like to say thank you to Lee for sharing your expertise. It's been fascinating to hear all about performance testing, and thank you all to the audience as well for participating in today's call. Lee, do you have any final words you want to leave the audience with?
Yes, just to say thanks to everyone. Just want to remind that it's very important to, first of all, analyze the scope, analyze what tools do I have in my hands, analyze how much money I will invest, and then starting from there, we can start thinking of what I am going to test, right? So it's very important to do the first part, which is the analyze. And then, rather than that, thank you very much for you guys for listening to me, and well, welcome to another webinar, maybe.
Super. Yep. As Lee mentioned, we do webinars on a frequent basis. So we will be doing webinars on different topics in the coming weeks. But we will, if you have any follow-up questions that we haven't got to today, you didn't have a chance to ask a question, then please also do reach out to us. Also, a recording of this webinar will be available within the next 24 hours as well. But with that, I want to say thank you to everyone for joining, and wish everyone a very pleasant rest of the day.